This is R.D. Sharma solution, class 12. Chapter 11, differentiation exercise is 11.3. Now we have to differentiate this tan inverse 5x divided by 1 minus 6x square. So this type of question we have just done, that there is also a limit being given, or the boundary being given. X should be between this and this, minus 1 by root 6 and plus 1 by root 6. So if you are not substituting anything, don't worry about the limit being given here. So we have tan inverse a plus b divided by 1 minus ab. Whenever this is the case, it is simply tan inverse a plus tan inverse b. So this is the say equality which we are going to employ in this question. Tan inverse 6x square we have here. 6x square can be written as 6 into x into x. 6 can be written as 2 into 3 into x into x. Okay. So this can be written as 3x into 2x. Basically 6x square can be written as 3x into 2x. Because 3x plus 2x, when we add, it will form 5x. 3x plus 2x is 5x. So 3x plus 2x here, 1 minus 6x square will be written as 3x multiplied by 2x. This is your a, this is your b. So a plus b divided by 1 minus a into b, and that will be equal to tan inverse a plus tan inverse b. A is 3x here and b is 2x here. That is why I told you the equality earlier, so that we directly put tan inverse 3x plus tan inverse 2x here. Okay. So this is why when we take dy by dx, tan inverse of anything, the differentiation is 1 by 1 plus square of that thing. So 1 by 1 plus 3x whole square. So this 3x differentiation is 3. Tan inverse 2x is 1 by 1 plus 2x whole square. And differentiation of 2x is what? 2. So this is the final. And 3x square is 9x square. And 2x square is 4x square. So just keep it like that. X is between certain two values, and we are not substituting anything. So don't worry about this limit. Okay. Try to make this inside thing. Something comes out of it which should contain a tan, because outside we have a tan inverse. So let me write this cos x plus sin x and divided by cos x minus sin x. So how can we make something out of it so that it contains tan? Divide numerator denominator by cos x. So cos x here, here also cos x, here also cos x. So what do you get? 1 plus sin by cos is tan x. Then this is 1 minus tan x. Now you know how to do this, because you know that tan a plus tan b by 1 minus tan a tan b is tan a plus b. And tan pi by 4 is 1. For tan 45 degrees 1. So in place of this 1, I am writing tan pi by 4. The denominator, assume this to be 1 into tan x. It is actually 1 into tan x. So tan pi by 4 plus tan x divided by 1 minus tan pi by 4 into tan x. So what do we get? Because this is tan inverse outside. And what is inside? Tan a plus tan b by 1 minus tan a tan b is tan a plus b. So you have tan pi by 4 plus x. So this is tan a plus tan b, 1 minus tan a tan b is tan pi by 4 plus x. Tan inverse is outside. Now since there is no substitution being done, only we have simplified, or we have converted this expression inside, so that this tan comes out, tan inverse gets cancelled. Pi by 4 plus x, this is y. And dy by dx is simply the differentiation of this pi by 4 plus x. This is a constant, so it is going to be 0. Differentiation of x is going to be 1. Differentiate tan inverse x raised 1 by 3 plus a raised 1 by 3 divided by 1 minus a into x raised to the power 1 by 3. So x raised a by a 1 by 3 and a raised 1 by 3. The denominator is ax into 1 by 3, which is essentially equal to a raised 1 by 3 multiplied by x raised 1 by 3. So let us separate it so that we get certain of that sort which we have already seen. For example, assume it to be p plus q by 1 minus p into q. If you have certain thing like this, it's basically an tan of something. That is tan inverse a plus tan inverse p. When you have tan inverse of, say, p plus q by 1 minus p into q, it will be tan inverse p plus tan inverse q. What is p here? X to the power 1 by 3. What is q here? It is a raised 1 by 3. So tan inverse x to the power 1 by 3 plus tan inverse a to the power 1 by 3 and divided by, this thing comes as tan inverse a plus tan inverse b. So this is how this formula we have been using and utilizing a lot. So now it will be clear to you. So you just have to differentiate this dy by dx. Tan inverse a raised 1 by 3, there is no x, so it is going to be 0. It is considered as a constant. And then we have 1 plus x to the power 1 by 3 whole square, because tan inverse of anything differentiation is 1 by 1 plus square of that thing. Differentiation of x raised 1 by 3 by product rule, the chain rule. So we have this 1 by, x to the power 1 by 3 differentiation let us do first. X raised n differentiation is n x to the power n minus 1. So you have 1 by 3 x to the power 1 by 3 minus 1. It is going to be minus 2 by 3. So since it is a negative, you can bring it down to the denominator. So it will be 1 by 3 into x to the power 2 by 3. So this is in the numerator, you can bring it down. So final answer will be 1 by 3, 1 plus x to the power 2 by 3, and this is in the denominator, so 1 by x to the power 2 by 3. Okay, this is final answer. Differentiate sine inverse 1 by under root 1 plus x square. So we will just substitute something inside this under root 1 plus x square so that we get something out of it, so that we get sine. So this is equivalent to under root a square plus x square. This under root 1 plus x square is under root a square plus x square. A is 1 here, x is x only. So x can be written as cot theta, x can be written as the tan theta. Why? Why we are not putting x as tan theta? Why we are putting as x equal to cot theta? Just because we have a sine inverse outside. We need something inside that results in something with sine, and that can only be retrieved only when we have x equals cot theta. So when you put x as cot theta, the inside thing goes under root 1 plus cot square theta. 1 plus cot square theta is what? 1 plus cot square theta is cosec square theta. From here x is cot theta, so x will be equal to cot inverse x. 1 plus cot square theta is cosec square theta. And since we have the root of cosec square theta, you are going to get cosec theta. If you take the under root, it will be cosec theta only. And cosec theta is what? 1 by sine theta. Or you can say sine theta is 1 by cosec theta. One and the same thing. So finally, the inside thing, which is 1 by under root 1 plus cot square theta. Under root 1 plus cot square theta is under root cosec square theta, which is going to be equal to cosec theta, and cosec theta is 1 by sine theta. So sine theta will go up. So finally we will get sine theta inside. Now there is no substitution, so you can just cancel these two out. So finally you have to differentiate theta. What is theta? Theta is cot inverse x. And cot inverse x is minus 1 by 1 plus x square. This is dy by dx. Okay. if y is equal to this, x should be between 0 and 1, you have to prove dy by dx is 4 by 1 plus x square. One time we have sine inverse, one time we have sec inverse. So let us put something in this x so that this sine inverse also get it to be solved, and sec inverse also gets something out of it. So one is this, the inside one. If we put x as tan theta, it will be 2 tan theta divided by 1 plus tan square theta. And this is nothing but sine 2 theta, we already know it. Then this one, 1 plus x square by 1 minus x square. Now if you put this as x as tan theta, it is going to be 1 plus tan square theta by 1 minus tan square theta. But we know 1 minus tan square theta divided by 1 plus tan square theta is going to be cos 2 theta. So there has to be some reciprocal here in order to get cos 2 theta. But we have a sec inverse outside. So we need to convert this sec inverse into cos inverse so that we get the reciprocal of inside thing, and then that ultimately gives you cos 2 theta. Because sec inverse x is cos inverse 1 by x. Or you can say cos inverse x is 1 by sec inverse x. So when you convert this sec inverse into cos inverse, the numerator and denominator will change position. So 1 minus tan square theta by 1 plus tan square theta. This is cos 2 theta. So cos 2 theta for second, and for 1 sin 2 theta. Now replace it. Sin inverse sin 2 theta plus sec inverse we already converted into cos inverse. And inside thing will become cos 2 theta as I just explained you. Okay. So cos inverse with cos 2 theta. Now just cancel these two out. So 2 theta plus 2 theta. And this is going to be 4 theta. Theta, you can replace it by tan inverse x. X is tan theta. So theta will be tan inverse x. So 4 into tan inverse x. So this is y. Now let us differentiate it. So this differentiation, before you remove the sine and sine inverse, that will has to be minus pi by 2 and pi by 2. And this again, this 2 theta has to be between 0 and pi if you want to cancel it this cos and cos inverse out. X is between 0 and 1. So let us use it. X is between 0 and 1. X is what? Tan theta. So tan theta and 0 and 1. Now apply this tan inverse, or find out the value of 0 and 1 when we have a tan. So theta will be equal to, means it is between pi by 4. 0 is of course pi by 0. Now we need 2 theta. So multiply 2 everywhere. So 2 theta will be 2 into 0 is 0 only, and 2 into pi by 4 is pi by 2. So 2 theta is between 0 and pi by 2, and which is there between 0 and pi and minus pi by 2 and pi by 2. So we don't have to worry about. So we just have to differentiate this. dy by dx is 4 tan inverse x. Differentiate this 4 into tan inverse x. That is 4 into 1 by 1 plus x square. So dy by dx we have to prove it to be 2 by 1 plus x square. X is between 0 and infinity. So you know by now how to check, how to do this. So I will directly do the solution without checking the 0 and infinity of x, the range. Because you know sin inverse sin theta will give you theta only between minus pi by 2 and pi by 2. Cos inverse cos theta will give you theta only when theta is between 0 and pi. So we'll put something here so that we get a sin inside. Here also we put something so that we get a cos inside. So this x is equal to tan theta we are going to replace. This is 1 and 2. So let us take 1, this x by 1 plus x square. So I am replacing it by tan theta by 1 plus tan square theta. This is our first one. Second one is inside, what is inside cos inverse? We have 1 by under root 1 plus tan square theta. So tan theta is sin theta by cos theta. Under root 1 plus tan square theta, under 1 plus tan square theta is sec square theta. And under root of sec square theta is going to be sec theta. And what is sec theta? It is 1 by cos theta. So just use 1 by cos theta, cos get cancelled, you get a sin theta here. 1 plus tan square theta again is sec square theta, under root of sec square theta is sec theta, so you get 1 by cos theta. So basically cos theta you will get. So what will be the final thing? Sin inverse sin theta plus cos inverse, and this is cos theta. Now if you want to cancel these two, you know these steps, and I'm just skipping this step because you know up till now how to do this. So theta plus theta will remain, it is going to be 2 theta. Y is equal to 2 into theta was what? Tan inverse x. So 2 into tan inverse x, 2 differentiation of tan inverse x is 1 by 1 plus x square. So y is equal to 2 by 1 plus x square is your final answer here. This one. Differentiate the following with respect to x. So you have a cos inverse sin x. The whole idea is to convert this sin into cos so that this cos and cos inverse can be cancelled. The whole idea is that. Okay. So how to do this? Cos pi by 2 minus x is sin theta, sin x that is, and sin pi by 2 minus x is cos x. And there are the relationship between tan and all these cot, sec, cosec like that. So let us convert this sine into cos by this. So cos 90 minus theta is sin theta. So in place of sin theta, just write cos 90 minus theta. So cos inverse cos pi by 2 minus x it will be. Okay. So just cancel it out. Pi by 2 minus x will remain, and this is your fx, which is y. So dy by dx is equal to pi by 2 is 0, and minus x, differentiation of x is going to be 1. So negative 1 it will be. Differentiate the following with respect to x. So you will be tempted to put something in place of x and trying to differentiate. That is also a way. The second way is directly doing it. Apply cot inverse formula of differentiation. Okay, rather than putting x somewhere. So cot inverse x is tan inverse 1 by x, or you can say tan inverse x is cot inverse 1 by x. So when we convert this cot inverse into tan inverse, it will be simply the numerator denominator will exchange the position, or it will be a reciprocal. So 1 plus x will go numerator, 1 minus x will go denominator. Okay. Now again you can place x as something, and you know that 1 can be converted to pi by 4, and denominator minus x can be converted into minus 10 by 4 into x. Then you have this formula is easy that we have seen. But rather than doing this, as I said, tan inverse theta differentiation, or tan inverse anything is differentiation is 1 by 1 plus square of that thing. Okay, so this is tan inverse of whatever is inside, 1 by 1 plus of square of that thing, which is 1 plus x by 1 minus x in this case. Now differentiation of this is also to be done by the chain rule. It will be differentiation of 1 plus x divided by 1 minus x. We just have to solve this first one and the differentiation of the second one. So let us do the differentiation of the second one. D by dx of 1 plus x by 1 minus x. So 1 minus x whole square in the denominator. So I'm using the quotient rule here. 1 minus x will be here. D by dx of 1 plus x will be, let us do it here, 1 plus x. 1 will be 0, x will be 1. So 1 only. Minus 1 plus x will come outside. And differentiation of 1 minus x. Differentiation of 1 minus x will be what? Differentiation of 1 is 0 and x is 1. So negative 1 will come out. So negative will become plus. So this x gets cancelled. 1 plus 1 is 2. So you have 2 by 1 minus x square. Finally you get a differentiation as this one. In the front we have 1 by 1 plus x by 1 minus x whole square. So we have to solve this also. So I am doing the denominator first. 1 by 1 plus x whole square, 1 minus x square. So 1 minus x square plus 1 plus x square. I am taking the LCM divided by 1 minus x square. Now remember, this was in the denominator. This was in the denominator, but that is 1 by this thing. So when you actually write it, this 1 minus x square will go in the numerator. So 1 minus x square, this is 1 by, okay. So 1 minus x square divided by 1 minus x square. Assume it to be, say, some p term. Total term is p. And this we already done twice by 1 minus x square. Cancel this 1 minus x square. So twice of 2 divided by p. What is p? So this solution you have to put in here. So let us open this 1 minus x square plus 1 plus x square. So a minus b whole square is a square plus b square minus 2ab. And this 1 plus x whole square is 1 square plus x square plus 2x. 2x cancel. So this is going to be 2 plus 2x square. 2 common you can take 1 plus x square. And denominator you have 2 into 1 plus x square. 2 gets cancelled. You have 1 by 1 plus x square. That is going to be your final result. Okay. This question will take in the next discussion. Till then, thank you so much and take care of yourself.